So for today's lesson, we're going to be doing the exact same thing as yesterday, just without fraction tiles. So this anchor chart tells you exactly how to do it. So to add fractions with like denominators, what are like denominators? Or like fractions? Mason. Like fractions have the same denominator. So if you hear like fractions or like denominators, it means the same thing. Fractions with the same denominator. So we have the addition problem, 1/5 plus 2/5. All you do is add the numerators as you normally would. So let's look at the numerators. 1 plus 2 is, class? 3. And then the denominator stays the same. Here's a little model. We have a whole that is broken into 5 pieces. 1, 2, 3, 4, 5. 1/5 is purple. 2/5 are blue. If we count them all together, 1, 2, 3, we get 3/5. So that's all you do. However, once you find that answer, your final answer has to be in simplest form. That's how fractions work. When you add, subtract, multiply, identify, when you do anything with fractions, your final answer must be in simplest form. That's where the extra sheet of paper comes in, because you'll have to find the greatest common factor on that separate sheet of paper so that you can find simplest form. We'll see what that looks like as we get into the lesson. So, go ahead and open your book to page 567. Page 567. Keep your anchor chart to the side because you can look back at it when you need to. And everybody should be open at page 567. Please read those sentences under the title, Victoria.
Think of adding like fractions as joining parts that refer to the same whole. To add like fractions, add the numerators and keep the same denominator.
That's all you do. Step 1, add the numerators. Step 2, the denominator stays the same. And then we have step 3, which is check for simplest form. So step 3 will always be check for simplest form, which means put the answer in simplest form. If it's already in simplest form, cool, you don't have to do it. But if it is not, that means if the numerator and the denominator have factors other than 1 in common, you need to put it in simplest form. Okay, go ahead and look at example 1. Okay, so everybody, finger or pencil on example 2. I'm sorry, example 1. We have a word problem. Read in your head while I read out loud. We're going to pause at every period and visualize. Pablo spent 2/6 of an hour on a jigsaw puzzle. Okay? I'm imagining he broke that hour into 6-minute increments, and he spent 2 of them on the puzzle. Conrad spent 1/6 of an hour on the puzzle. Conrad broke 1 hour into 6 10-minute increments, and he spent 1 of them on the puzzle. How much time did they spend working on the puzzle in all? Remember, those words, in all, give you a hint that you are putting numbers together. What operation do we put numbers together? Aaron? Addition. So in all together are both hints that you're going to be adding the numbers. So we're going to add Pablo's 2/6 of an hour to Conrad's 1/6 of an hour to find out what part of an hour they spent in all on this puzzle. So, step 1, add the numerators. Class, what's 2 plus 1? 3. Then, keep the same denominator. What's the denominator of our add-ins, class?
6.
So the denominator of our sum is?
6.
Sorry, I said the denominator of our sum is 6. So that means 2 sixths plus 1 sixth equals 3 sixths. Now the next step, write it in simplest form. We know that 3 is prime but 6 is not. So what do we use to find simplest form? Carla, greatest common factor. So let's go head over to the side and list the factors of 3 and 6. Carla, what are the factors of 3?
1 and 3.
1 and 3. What are the factors of 6?
1, 2, 3, and 6.
What are the common factors?
1 and 3.
What's the greatest common factor?
3.
Now on your tests, your math tests, some of you listed all the factors of both numbers, but for whatever reason, circled a smaller number. There was one in particular, 18/27. And there were quite a few of you that listed the correct factors. But then a few of you said this. But first of all, if we look closely, we see that 9 is actually the greatest common factor, and you had it there. You had the 9 for both of them, but because you're working so fast and you're only thinking of the obvious, you miss what you have right in front of you. Then, if we look at these numbers, we know 6 and 9 both have what as a factor? Colin? 3. Simplest form can only have what as a factor? 1. So, be careful. Pay attention to what you're doing. Okay, so now we know the greatest common factor of 3 and 6 is 3. So we're going to take the answer to our addition problem, 3 sixths. We're going to divide the numerator and the denominator, each by 3. Class, 3 divided by 3 is?
1.
6 divided by 3 is?
2.
We see that 1/2 is exactly the same. It's equivalent to 3 sixths. So they spent how much of an hour on the puzzle, class?
1/2.
1/2 of an hour. So when you are adding fractions, your final answer must be in simplest form. If you have been practicing with greatest common factor like you should have been, you are at the point where you can quickly tell the factors of these small numbers that we will mostly be working with. So it will be no issue. However, if you have not been working and you have just been rushing through and finding the most obvious answer, it will not be so easy for you. So, when we add fractions, add like fractions. Step 1, add the numerators. Step 2, denominator stays the same. Step 3, check for simplest form, and then put it in it if it needs it. Okay, let's look at example 2. Read in your head while I read out loud. Find 3/10 plus 5/10. Okay. Step 1. Add the numerators. Class, 3 plus 5 is 8. Then, the denominator stays the same. Class, the denominator of our addends is
10.
So the denominator of our sum is 10. Next step, check for simplest form. Well, let's list the factors. Who would like to help me list factors of 8 and 10? Keep your hand up. Everybody should be able to do this. These are small numbers. Let's model. Victoria, help me model. First we just think of the numbers in order from 1 to 8. And think, are they factors? And how do I know? So let's start with 1. Is 1 a factor of 8? How do you know? Because 1 times 8 equals 8. Is 2 a factor of 8?
Yes.
How do you know?
Because it's even and 2 times 4 equals.
So there's 2 ways we know. 8 is even, and because 2 times 4 equals 8. Is 3 a factor of 8? No. 3 times 2 is? 3 times 3 is? 8 is in between 6 and 9, so 3 is not a factor. What about 4? Do we even have to try that? Why?
Because it's already up there.
It's already up here. We've already met in the middle, so we don't have to keep thinking. Let's do the same thing with 10. Is 1 a factor of 10?
Yes.
How do we know?
Because 1 times 10.
Because 1 times 10. Is 2 a factor of 10?
Yes, because 2 times 5 and it is even.
Yes, because 2 times 5 equals 10 and 10 is even. Is 3 a factor of 10?
No.
No, because 3 times 3 is 9 and 3 times 4 is 12 and 10 is between. What about 4? No, because 4 times 2 is 8 and 4 times 3 is
12.
and 10 is between. So 4 is not a factor. Now 5. Do we have to try it? No, because it's already up there. So we can stop. So what are the common factors of 8 and 10, class? 1 and 2. What is the greatest common factor of 8 and 10, class?
2.
So we're going to take 8/10. We're going to divide the numerator and the denominator, each by 2. Class, 8 divided by 2 is?
4.
10 divided by 2 is?
5.
So 3/10 plus 5/10 equals 4/5. Remember, your final answer is in simplest form every single time. I have a feeling there's going to be a lot of wrong answers on this homework because you're either not going to check for simplest form at all, or you're going to rush through and just think of the most obvious answer, like when we had 18/27, and then you're not going to have your final answer in simplest form. There's going to be like 6/9. There's something other than 1 that they have in common, and that's not simplest form. So make sure that you are finding simplest form. Don't get points off on this pretty easy lesson because you don't try to find simplest form. You're going to have all small numbers that are very quick and easy to find factors of, especially if you've been practicing this whole time and you don't even have to think about the factors of 8 to know that they're 1, 2, 4, and 8. Pay attention. Go slow. There is no excuse to not get a 100 on this math homework. Do you agree? Because most of it is just adding 1-digit numbers. And then finding factors of numbers that have all basic facts. So, Go slow. Pay attention to what you're doing, and you will do just fine. Okay, let's look at the guided practice. Okay, here's where we're going to practice showing our work on the separate sheet of paper. Because even though we have space, for those of you who after number 2 are ready to just go ahead on your own, I want to show you how to use your separate sheet of paper to figure out if it's in simplest form. Okay, the directions for numbers 1 and 2 say find each sum, write in simplest form. So number 1, we have 1/6 plus 2/6. Zadie, what do we do first?
You add 1 plus 2.
Well, every time, even down here?
No.
So what do we do in words? No numbers.
You add the numerators.
We add the numerators. Okay? Now, the numerators are?
1 and 2.
So 1 plus 2 is?
3.
Next step, look back.
The denominator stays
The denominator stays the
the same.
same. The denominator of our add-ins is?
6.
So the denominator of our sum is?
6.
Now, next step,
See if it's in simplest.
see if it's in simplest form. 3/6. Are those both prime numbers? No. So we need to go to our separate sheet of paper, write number 1, and then we need to list the factors of 3 and 6. Zadie, what are the factors of 3?
1 and 3.
What are the factors of 6?
1, 2,
Go through the numbers. So we have 1, 2 is, use that strategy that I told you. Okay, let's do that right now. Use it. It will help you. It's not there to make you do extra work. If you don't use it, you could end up doing extra work. So let's use that strategy. Is 1 a factor of 6?
yes.
How do you know?
Because 1 times 6.
Because 1 times 6. Is 2 a factor of 6?
Yes.
How do you know?
Because 2 times 3.
Is 3 a factor of 6? Yes or no?
Yes.
How do you know?
Because 3 times 2.
Because 3 times 2, but also we know because it's already up here. So do we have to keep thinking of 4 and 5 before we get to 6? No, because we've already met in the middle. So now, what are the common factors?
1 and 3.
1 and 3. What's the greatest common factor?
3.
3. So now that we've found the greatest common factor, we're going to go over to our answer because I want to see both. I want to see the original answer, I want to see the answer in simplest form, and how you got there. So we're going to come over back to our paper. We're going to divide our numerator and our denominator each by our greatest common factor. Zadie, 3 divided by 3 is?
1.
6 divided by 3 is?
2.
So 1/6 plus 2/6 in simplest form is?
1/2.
1/2. So I want to see both on your paper. Exactly the way we did number 1 is how you're going to do every problem unless it's already in simplest form. Number 2, we have 2/5 plus 2/5. Cullen, what do we do first?
We add the numerators.
Add the numerators. What are our numerators?
2 and 2.
So 2 plus 2 is?
4.
Next step.
The denominators stay the same.
The denominator stays the same. What's the denominator of our add-ins?
5.
So the denominator of our sum is?
5.
Now let's think. What do we do next?
We write it in simplest form.
We check for simplest form. Is 4/5 in simplest form?
No.
Factors of 4. Use that strategy.
1
You can use that strategy in your head.
Okay. 2 and 4.
Factors of 5.
1 and 5.
What are the common factors?
1.
So greatest common factor is,
1.
which means
We divide. It's already in simplest.
it's already in simplest form. Now, if you know that the numbers you have nothing in common other than 1, you know it 100%, because you know the factors of 4 are 1, 2, and 4, and you know the factors of 5 are 1 and 5. You don't have to do all this. However, if you know that they have a factor in common, you need to do this, because the more you do it, the easier it is. So for number 2, if you knew that 4 and 5 had nothing in common other than 1, you didn't have to do that. Okay? But like number 1, where you know they do have something in common other than 1, you need to list factors. But again, you are listing factors of numbers between 1 and 12. So do I need to hear a bunch of complaining about having to find factors? No. Because all you have to do is you can do that strategy in your head. Okay, is 1 a factor? Yes, I know that because 1 times 3. Is 2 a factor? No. I know that because 1 times 3 is 3, and 2 times 3 is 6. So it's not a factor. You need to think. You can do it in your head, or you can do it where you spread them out and you do it by factor pair. Just take the time to do it. If you got to number 2 and you weren't sure, then yes, list factors. Obviously. It's better to list factors and find out, oh, they don't have anything other than 1, than it is to guess and get it wrong. Take the time, put in the time and effort to get the grade that you deserve. If you do not put the time and effort in, well, then you deserve whatever grade you get. Mason, what's your question?
I think 12, 13, or 14 are exactly like yesterday's math.
So let's look at the independent practice. Okay, so let's look at the independent practice and the homework to see what you're going to be doing. Then those of you that are ready, you may just continue. And I will do numbers 3, 4, and 12 for anybody who might just need a little extra. Okay, so numbers 3 through 11, you're doing exactly like numbers 1 and 2. Once you get to the final answer, if you know 100% without a doubt that it's in simplest form, move on to the next one. If you are not sure or you're questioning yourself, find the greatest common factor on your separate sheet of paper, then show the division, the original answer, division, final simplest form answer on the paper. Yes?
I think this is kind of true because on number 2 we did the same thing. We took 2 fish and we added it twice, and we got simplest form. And we've been adding on the rest of the examples the 2 fractions that aren't the same. So I think that's just a theory, not true, maybe. But if you have the same fraction and you add it twice, it may be simplest form. But I don't know.
What does it equal?
That equals 4, 6.
Is 4 6th in simplest form? So is that true? Nope. So we're not looking for coincidence. That's a coincidence. It's not how it always is. So do not think just because the numerators are the same, you're going to end up with an answer in simplest form, because that's not true. Because look, both of these numbers are even, which means automatically they have at least what in common? Mason? 2. So that's just a coincidence. Okay? That's an observation you can make, but not a rule or a pattern. Remember, observations are not the rule. So just because it happens once doesn't mean it's going to happen every time. Okay, so let's see, 12 through 14 are just like what we did yesterday on numbers, I think, what, 12 through 14? No, 6 and 7. Where first you find the fraction and you write the equation with unit fractions. Then you write another equation for it. We'll do number 12 together if you're confused about that. All you do is first you write the equation with the unit fractions. Remember, unit fractions, what are they? Zari.
Unit fractions have a 1 as the numerator.
Unit fractions have a numerator of 1. Then you write one other way to get that answer. Look at the back. Numbers 13 through 17 are word problems. Remember, you need the equation, the answer in simplest form if it's not already in simplest form, and the unit. So for word problems, I'm going to put a checklist on the board. You need 1, the equation. 2, the answer. 3, simplest form. If the answer is already in simplest form, obviously you're not going to write it again. And then you need the unit. Here's your checklist. There's no excuse to not have all of these things. In fact, later on, once you're on your own, if you want to write this on the back of your homework so that you're sure you have all of those things, go ahead and do that. Not right now, but later, when it gets to time for you to go by yourself. Now look at the homework. Numbers 1 through 4 are exactly like our guided practice. So you need the original answer. Then you need to go to a separate sheet of paper to find your greatest common factor. Then you need to have the division and the answer in simplest form on the line, just like the guided practice numbers 1 and 2. Numbers 3 through 11 on your independent practice, and numbers 1 through 8 on your independent practice, on your homework, need to look exactly like the guided practice. Original answer, finding greatest common factor on your separate page, division, and simplest form answer on your math page. Does everybody understand how to show that? If you forget, go to numbers 1 and 2 on the guided practice and do it the exact same way. Numbers 9 through 11 are word problems. Just like the independent practice, you need the equation, the answer in simplest form if it's not already, and the unit. Show your greatest common factor on your separate sheet of paper, just like you did on independent practice. Any questions about what to do for, number 12 is a multiple choice, but you still have to show the equation, the answer, simplest form, and unit, and then bubble in the correct answer. If you do not show work for number 12, you will lose a point at least. Because other than that, it's just a guess. Even if your guess is right, could have been a coincidence. And coincidences are not the final answer. Mason.
The only class one on the homework, but that's different is
Mhm.
with one.
Okay, so yeah. Zadie.
On the back of my homework, there's something on it. I don't know what it is.
Well, you can trade it for the extra one if you want.
Okay.
Yes.
So when we are doing the lab, I was like,
If you are ready, go ahead and start working on independent practice on your own. If not, as soon as I answer Carla's question, I will do numbers 3, 4, and 12.
so,
I might do 3, 4, 5, and 12.
okay, so on the lab, when we're doing the exercises, can we do the back to
Can you what?
Can we do it for all of them so we can?
I'm not really sure what you're saying. Sadie?
I think I know what she's saying. Like, even if you know it's already in simplest form, go ahead and.
Yeah, sure. If you know, it's just you have to show this if it's not in simplest form.
Oh,
If it is in simplest form and you know it 100%, you either don't have to show the factoring or you can for the practice. Yes, that's fine.
okay.
Just make sure that you do have it if it's not in simplest form, otherwise you'll lose that extra point. Okay, so number 3, even if you're working on your own, if I pick your stick, you're helping me. Smith, number 3, we have 1/3 plus 1/3. What do we do first?
Add the numerators.
1 plus 1 is?
2.
Next step,
The denominators stay the same.
so our denominator is?
3.
Next step,
Check to see if it's in simplest form.
is 2/3 in simplest form, or do we need to factor it?
It's in simplest form.
It's in simplest form because factors of 2 are,
1 and 2.
factors of 3 are,
1 and 3.
so they only have
1.
in common. We know that just by looking at it because 2 and 3 are both
Prime.
prime. Very good. Okay, number 4. I think we're going to do 3, 4, and 5, and then 12. Kingston's not in here. Lena, number 4, 2 6 plus 3 6. What do we do first?
We add the numerators.
2 plus 3 is?
5.
Next step.
And then denominator stays the same.
So our denominator is?
6.
Next step.
Next, we find the greatest common factor.
Okay. If we factors of 5,
1 and 5.
factors of 6,
1, 2, 3, and 6.
common factors,
1.
greatest common factor, which means
It's in simplest form.
5, 6 is in simplest form. Number 5, Michaela, 3/8 plus 1/8. What do we do first?
Add the numerator.
Add the numerators. 3 plus 1 is?
4.
Next step.
Add the denominator stay the same.
The denominator stays the same. So our denominator is?
8.
We do not add the denominators, ever. Anytime we're adding fractions, whether we have like fractions or unlike fractions, we never add the denominator. Okay, what do we do next?
Check to see if it's in simplest form.
Check to see if it's in simplest form. Is it?
Yes.
You're just going with the most, you're just guessing. Look at those two numbers. We know no matter what, they're not in simplest form because they are both what type of numbers? Even. Which means they have at least what factor in common?
2.
At least. So what do we need to do to find the simplest form? What have we done every time we needed to find simplest form? What did we find?
The greatest common factor.
The greatest common factor. So what am I doing to find greatest common factor?
You're finding them for 4 and 8.
I'm finding factors for 4 and 8. Okay? Factors of 4,
1, 2, and 4.
bless you. Factors of 8,
1, 2, 4, and 8.
common factors,
1, and 2, and 4.
slow down. Do you see how you said, oh, it's in simplest form, and then here you stopped at 2 until you saw me try to go to the next one? Slow down and look closely. What's the greatest common factor?
4.
So what do I do with that greatest common factor?
Divide it each by 4 and 4 eighths.
So divide the numerator and denominator each by our greatest common factor, which remember I'm going to show on the math book page. 4 divided by 4 is?
1,
8 divided by 4 is?
3.
8 divided by 4 is? Remember, division is backwards multiplication. 8 divided by 4 is 2 because 2 times 4 is 8. So 3/8 plus 1/8 in simplest form is 1/2. So make sure that you show all of that work. Otherwise you will lose points. Every problem that is not in simplest form is worth 2 points. Or 3 actually. 3 points. 1 for the original answer, 1 for showing your work and the division, 3 for the simplest form answer. If you don't show this to get simplest form, you lose 2 points. If you leave an answer that is not in simplest form, bless you, you lose 2 whole points. Do not lose 2 whole points just because you're going way too fast and you're not really thinking. Let's do number 12, then I will answer questions. Number 12, the directions say write each fraction as a sum of unit fractions. Then write an equation to decompose the fraction in a different way. Carla, so first we have to take 4/5 and we have to write it as a sum of unit fractions. What does that look like?
1/5
1/5
plus 1/5
plus 1/5
plus 1/5
plus 1/5
plus 1/5.
plus 1/5. Are we done? Or do we have more?
That's it.
That's it. Whatever our numerator is, that's how many unit fractions we add together. Our numerator is 4, so we have 1, 2, 3, 4 unit fractions with 5 as a denominator. Good, so there's the first part. Now we need to write a different addition equation that will give us the answer 4/5. So what would you like to write? There are several options, but you only have to pick one. So what could we do? What's another addition problem that we could write where the answer would be 4/5?
2/5 plus 2/5.
2/5 plus 2/5. Okay. Any questions? Victoria.
On number 7, it says 3/10 plus 7/10, and that equals this. Okay.
Make sure it's in simplest form. That's all I can say. If you have a question about our particular problem, you may come to me. Please come to me if you have a question about a particular problem. Don't just guess. However, also make sure that your answer that you know is correct, make sure it actually is. Make sure you're not just rushing and putting the first answer that comes to your head. Make sure you're putting all correct answers. Put the time and the effort in to get that 100 that is very, very attainable. Attainable means you can get it. Okay, now I will take individual questions if you have them. Keep working.